Okay, so the session is recorded now, is being recorded. Yeah.
Yeah.
The today is the LO2, understand the network management protocols and standards. Yeah. So mostly the topics, into this LO are, the OSI model and the TCPIP model. So do you have any idea about the TCPIP and the OSI model?
No, I have not studied it in detail.
Yeah. Okay, no worries. Yeah. So we will start from the scratch now.
Okay.
So the unit names are same. Now let us see. You must be, reading somewhere OSI or ISO, isn't it?
Yeah.
Yeah. So basically the layering model is OSI. Yeah, which stands for Open System Interaction.
Okay.
Yeah. However, the organization that developed the model is ISO, International Organization for Standards. Yeah, is that clear?
Yeah. Yeah.
So now let us see what the standards are. The standards are documented agreements, yeah, containing technical specification. So are the other precise criteria to be used consistently as a rules, guidelines, definitions of characteristics to ensure that the materials, products, processes, and services are fit for their purpose. So when you really want any communication or any way of dealing via an agreement is basically that both of the parties would be relying on the same number of rules. Yeah, nobody would be violating. Then you sign up with an agreement, which becomes basically a kind of standard. Yeah.
Yeah.
So when it is the standard, then both of the parties would be using the same standard. Yeah.
Yes.
Now further, let us see that what the layering is. Yeah, basically the term layering or interfacing is used into the models. Basically the model or the standard, whatever the standard you want to use, it could have some components and it could have an arrangement as well, isn't it?
Yes.
Yeah. So layering is important concept in the computing. The way the layers are defined, for example, if the computer is in front of you and the way you can touch the keyboard, you can touch the screen, it is a kind of one layer, isn't it?
Yes.
Yeah. And if when you enter into the communication, it's another layer. And when the data reaches to the computer's internal hardware like a zeros and ones, then it's another layer. Make sense?
Yes.
Yeah. So the computer, the data, when the computers want to communicate, yeah, with the triggering of the user, it crosses from different layers, yeah, and reaches to certain endpoint. Yeah.
Okay. Yeah.
So whenever a user runs an application, the user interfaces with the application. For example, we are directly interfacing with the screen of the uh, computer. Yeah, in a sense that we are dealing with the, let's say, this Microsoft PowerPoint, the presentation mode, isn't
Yeah.
it? Yeah. Then the application interfaces with the operating system. So whatever the application is running, it has a tight integration with the operating system, isn't it?
Yes.
Okay. Then furthermore, the operating system interfaces with the BIOS. Yeah. So what are the BIOS?
The input-output system.
Yeah, the basic input-output system. So for example, whatever the interface, like in front of my screen, these are the fonts. Then it has a direct connection furthermore with the inputs like a keyboard, with the mouse, yeah. And if any data is going through, reaching to you, then everything is being furthermore, handled, yeah.
Yeah.
Then furthermore, the BIOS interfaces with the input-output hardware, yeah. So
Yeah.
like hardware, it could be the monitor, yeah, and input could be the keyboard or the mouse, and furthermore, the other hardware like a network, yeah, and a network card as well, yeah. And
Yeah.
it could be considered as the specialized, the input and output, because if the data is leaving the network card, yeah, then it could be as an considered as a output device, yeah. If I'm the same device is receiving your signal, your voice could be considered as a an input device, yeah.
Okay. Yeah.
So the layering concept is behind in this way, that every overall the computing is being carried out, yeah, using the layers, right?
Yeah.
Now, to what purpose? What's the purpose behind this? Because if there are the layers, then the user need only know something about the application and doesn't need to know the details about the operating system, isn't it?
Yeah.
Because if we want to use the PowerPoint, yeah, if we want to use the join me, then we
Mm-hmm.
don't need to worry about how they are communicating, yeah, and what type of the communication, the bandwidth, the way they are connected, whether it is the synchronous or synchronous, what type of connection it is, yeah. We don't need to know anything about it, yeah.
Yeah.
So don't even not operating system, not the BIOS. Yeah, how the let's say join me software is getting the voice from microphone and sending the voice to the speaker. We don't need to know. Yeah. Similarly, the application needs information about the user and the operating system, but not the BIOS or hardware. So same way, when the join me wants to know something, yeah, they would be talking to the operating system directly. Do you think that the join me would be directly working into the hardware?
No.
No, it would be getting the help from the operating system.
Yeah.
For layering to be successful, there must be a standard interface into the layer. Makes sense?
Yeah.
How? For example, the operating system is capable to run the different applications. Yeah. For example, the operating system has particular standard to run the applications. For example, when we say if it is the Windows application, yeah, then the other application from the other operating systems like Linux or the Macintosh or the Mac operating system, they won't
Yeah.
be running on the Windows. Yeah,
Yes.
yeah. Then the Microsoft Windows expects that the every application should be fulfilling the standards that the Windows accepts. Yeah.
Yeah. Okay.
So yeah, so those should have been layered into according to the standard, and the standard is the agreed upon, terms and conditions of the software. Make sense?
Yes.
Okay. Now the communications layering. The communication between the one or two users on a network similarly is broken down into the layers. A possible model for this layering was laid out by the ISO. Yeah, laid
Yeah.
by ISO, not the OSI. Make sense?
Yeah. The
Yeah,
organization.
yeah, because the organization led the layering. Yeah. So
Yeah.
when we want to create the communication, then there has to be layering, like the concept we discussed. When we use the application, then it further communicates with the operating system, and the operating system further communicates with the actual hardware of the computer. Yeah.
Yes.
Now we come to the OSI. Yeah. So the OSI is a reference model, yeah, which was proposed by the ISO, yeah, which serves as a reference model. Yeah, a reference model is a kind of everyone needs to refer this model for how information is transmitted between any 2 points in a network. Yeah, like a protocol, the way the rules. For example, if someone wants to travel, yeah, from one country to another country, then they will have to exit via the immigration of the one country. Yeah, the immigration exit control, list. And then when somebody is reaching to another country, then again they need to meet the immigration of the destination country, isn't it?
Yes.
Yeah. So it has to go through, the way the same rules, because the same rule is, for example, they need, the passport, the travel document, and if as well as the visa. Yeah. The destination country should have either the visa or, the nationality of the same country. Yeah. So the OSI reference model works in this way, for example. Yeah, it's because it's a kind of travel, and travel could be considered as a transfer of something, the self transfer, isn't it?
Okay.
Okay.
Yeah.
So it guides the manufacturers, also called as vendors, so they can make the products that will work with other products. Yeah. So the way, for example, there could be the number of companies, yeah, which are selling the wireless network cards, yeah, or the routers, yeah. They must be relying on the standards, yeah, and they must be following the same interfaces, which could be accepted by every hardware. Yeah.
Okay.
The OSI model is comprised of 7 layers that are involved in the communicating between two nodes of a network. So what are the 7 layers? For example, if you want to transmit the data, yeah, from your computer, then you need to uh, send it via the application layer first. Then it has to go through the application layer, sorry, the presentation layer, then the session layer, then the transport layer, then the network layer, then the data link layer, then the physical layer. Yeah.
Yeah.
Then when it is sent, and then when it is received, yeah, then when it is received, then the receiving layer is the reverse of the sending layer. Yeah.
Yeah.
It won't be the case if the data is being sent, yeah, from the application layer, then the receiver would be receiving this at the application layer. Make sense?
Yeah.
So they would start receiving from the physical layer, then the data link layer, then the network layer. Now it is important to know that what these layers do actually. That's basically, we have to understand now. Yeah.
Yeah.
Now, what happens? The OSI model is basically a kind of combination of the computer as well as the network, isn't it?
Yeah.
Because what happens, you use the computer to send your data to another computer which travels via the network. Yeah. So the OSI model covers both of the things. Yeah. And in between there is a middle division. Yeah. So the transport layer can be viewed as a division between the computer and the network. The lowest 3 layers, physical, data link, and the network, yeah, deal with the best effort to get the information to the desired computer. The transport layer verifies the efforts and hides the network from the layers above. Remaining layers treat the data as if it was a local. What happens? The transport layer, yeah, for example, decodes, yeah, the data into the further lower layers, yeah,
Yeah.
and then what happens at the receiver side, until the transport layer, all the raw data or the more details are furthermore converted to the application layer, yeah, without exposing the details that how that was transmitted and converted into the particular data format.
Correct.
Yeah.
Yeah.
Now the first layer, yeah, the physical one. A physical one is not the application layer basically. Yeah, when we say we have the screen in front of us, that's not basically the physical layer, isn't it? Yeah, basically that's the screen is showing you the application.
Yes.
Yeah. So the physical, there is no interpretation at this level. A stream of zeros and ones are put into the form convenient for the transmission. So when the data becomes a pure zeros and ones, yeah, obviously the data will be in the zeros and ones, and the corresponding instructions, yeah, for the interpreting other things would also be in the zeros and ones. But overall, a whole program, yeah, which would instruct that the way where the system would leave, you know, would be the physical layer, yeah, the forms of the zeros and ones, yeah.
Yeah.
This level is the most hardware oriented. It includes the specifications about network interface cards, types and length of the cable, the voltage characteristics, range, level, age, etc. It means, for example, after this physical layer, yeah, this would be communicating with the router of your network.
Okay.
Yeah. So for example, the data is purely, into the zeros and ones, and then being transmitted via the NIC card. Yeah. And the, for example, if it is sent via the, the cable, then would be considered as a cable. It could be sent via the wireless application protocol as well, and the range of the particular frequency, isn't it?
Yes.
Yeah. So the physical layer is basically the last layer into the computer, yeah, which would be dealing and sending or receiving the further, data being sent over the network. Yeah.
Okay. Yes.
Furthermore, the physical layer involves the protocols, the Ethernet, FDDI, RS-232, the ATM one. Yeah. So, like if you recall, yesterday we discussed that over the LAN, yeah, like if we look at the physical topology, yeah, then they
Yeah.
look like the a kind of mesh, star, or bus, and when
Yes.
how the data is being transmitted, the way the data is being transmitted would be
Logical.
known as a logical topology.
Yeah.
So at the physical layer, these, the topologies are further, being implemented in order to transfer the data between, let's say, the computer and, the until the router, yeah, because the router has a further, in between the router and, the computer, there is a further lane existing, isn't it?
Yes.
Yeah, it has to pass through the lane, and then the lane is further extended to the WAN using the internet. Yeah.
Yeah.
Okay. So it was about the the physical layer. Yeah. Now we come to the next layer above the physical layer, which is the data link layer. At this layer, one begins to consider the bytes instead of just bits. One examines some of the information content of the signal. Recall that the bridges operate at this level. They know where the packet is headed. They know whether or not it has been involved in a collision. Bit stuffing occurs at this level. So again, at the physical, layer, so basically a kind of lane card, yeah, is there, yeah, in your computer, and
Okay.
a layer into the lane card, your networking, device, yeah, this layer converts those, bits. What we say a bit is a binary digit, either 0 or 1, yeah,
Yes.
into bytes, yeah. If the data is entered into the system, then it would be into the bits. Then the bits would be compiled further to make a further larger unit into a byte, yeah. Because
Yes.
byte would be a one meaningful and the addressable unit, and from the bytes you create, the word, and from the word you create, the more information in order to show or interpret those number of bytes into a kind of application, into kind of data, and the further the data would be able to show into the application. Make sense?
Yes.
Into the further, layers. Yeah.
Yeah.
So after the physical layer, you enter into the data link layer. Yeah. So the data link layer is a kind of, if if the data is received from other, computer, then the bits would be converted into the bytes. But when it comes to if you are sending the data, then it is traveling from the upper layers, then until the bytes, and the furthermore the data link layer would send the data and divide the data into the bits. Yeah.
Yes.
Okay. So furthermore, within the data link, the data packets are encoded and decoded into the bits. It directs the packets and handles errors from the physical layer. It handles the synchronization, the timing. It must know where one bit ends and the next one begins. It must know where the one byte ends and the next one begins. Yeah. Obviously, that would be a kind of chopping of the data into the bits and bytes.
Yes.
Yeah. So the data link layer is clear now. Yeah. So within the data link layer, yeah, there are sublayers. Yeah. One is the media access control sublayer, which takes the signals from or puts the signals into the transmission line, yeah, physically. And then there is the logical link control sublayer. It starts to interpret the signals as a data, including timing and errors. Yeah. So like I explained earlier, that the data link layer is again sitting into the, let's say, the network interface card. Yeah. And if you know or remember, that network interface card has a unique address, the media access control address as well. Have you heard about it?
Yeah.
Yeah. So every device has a media access address. So it also responsible for, the accepting or sending the signals, and furthermore a unit inside the, the network card logical link control, that would be actually interpreting the signals. Yeah.
Yeah.
Interpreting the signals, checking the timings that the signals and the data is coming through the bits, yeah, into the sequence. And if those, the chunks of the data are received without any error, then should be fine. Otherwise, they would be repeating. So what happens, it's not always the case. For example, if my voice is being transmitted to you, yeah, then each and every packet of the data must have been delivered without any loss. No, there would be lots of data packets which would have been, lost, yeah, and being resent into the milliseconds.
Oh, okay.
Yeah. So that's the logic behind. In the network, it's not 100%, the case that every data packet being sent is definitely and guaranteed to be received over there. There could be many chances, yeah, that the data would have been sent repeatedly many times. Yeah. That's
Yeah.
the basically the logic behind these, layers. Normally, what we say when we try to load the, server, yeah, and our when the web page is coming to us, then it comes to us after lots of the transmission of the data over a repeated and the missing data resent. Yeah.
Yeah.
Now the network layer. The network layer is router acted at this layer. Yeah. Somehow the sequence is interchanged. Yeah. But the network layer is being laid at the layer 3, and however this should have been on the bottom, isn't it?
Yes,
If
correct.
you imagine.
It
But imagine that this OSI layer is basically a kind of hypothetical, a virtual, the abstract model basically. Yeah. Then the network layer is actual router. One of the main functions, of the layer is routing. Yeah. And store and forward are network layer functions. If you recall, then the router uses the routing, and the routing is basically the kind of protocol, the way the data or the communication is being created from one point to end point. Yeah. And that's basically the routed thing. Yeah. And the routing is basically that dynamic paths are being identified. Yeah. Why the dynamic paths are being identified? So that the data could be sent quickly. Yeah. And in this way, if like we discussed in the previous layer, the data could be lost. Yeah. So in order to avoid the loss of the data, the delay into the data, the the router is being used. Yeah. At the network layer. Yeah.
Okay.
In a connection-oriented scheme, the virtual circuit is established at the network layer. Yeah. So the connection-oriented is that, for example, if you are browsing the web, yeah, when you are sending the HTTP request, the data comes to you. It is the non-connection oriented. Yeah. You sent a request. Yeah. And then the response comes to you, then your connection is terminated in between you and the server immediately, because the output is coming into the response. Yeah. However, if the voice chat is being carried out, yeah, that is basically a connection oriented network, isn't it?
Yes.
Yeah. So every time the connection is being built, yeah, and maintained. So furthermore, building the routing tables, troubleshooting the routing tables when there is a lot of traffic, for if a connection goes down, the network layer also gathers the related packets. So again, in the same network layer, the connection could be the connection oriented or the connectionless. So for example, if the connection is being made and it is a connection oriented, then it is the responsibility of the network to continuously create the routing table. Yeah. For example, from my IP address towards your IP address, and the connection table is being maintained every time, for every second, for every chunk of data, for minimum, the voice is being converted into the digital one. So that is the responsibility of the network layer.
Okay.
Yeah.
Yeah.
Then the transport layer is stated before. The layer 4 is dividing line between the computer transactions and the intra-computer transactions, where the computer collects and further disseminates the data to the network. Yeah. So this transport layer, the layer 4, manages the end-to-end verification. Yeah.
Yeah.
So like the data is ready to leave the computer. It would reach to the transport layer via the network interface card. Yeah. And the lower layers makes the best effort, but if the data is lost to the layer 4 must ensure that the information was received intact. It does a higher order error checking. The transfer should be transparent. The higher layers do not know the data came from the another computer. So here the transport layer would not be giving the details for example, if it was received from the physical link layer, data link layer, and the network layer to the further layers. Make sense?
Yeah.
Yeah. In the same way, its responsibility is to code and decode in between the communication. Yeah.
Okay.
So furthermore, the data packets are encoded into and decoded into the bits. It directs the packets and handles errors from the physical layer. It handles the synchronization. It must know. Sorry, we are on the transport layer. Yeah.
Yeah.
So the transport layer is in between, the computer and the network, and it further, keeps the higher information. Yeah. And does not, gives the detailed information to up or down towards the layers. Make sense?
Yes.
Okay. Then the session layer. When discussing the connection oriented, yeah, schemes, we talk about a session basically. What happens, if you want to know that you are connected, then you are basically being maintained by a session. For example, if you are doing the kind of shopping via a shopping cart, yeah, and whatever the items you are putting into the shopping, and while you are on the same website, your session is maintained. Yeah.
Yes.
Have you heard about this session before?
Yes.
Yeah. So the session management is done especially when you want the connection oriented, communication. Yeah. So furthermore, if required, yeah, you wanted the connection oriented, yeah, you would be using the session layer into the OSI model. Yeah. So this layer establishes, manages, and terminates the sessions between the application. They could be on the same computer or on the different layer. Yeah. So furthermore, then there is a presentation layer. Yeah. So the presentation layer is the way that the data needs to be finalized. Yeah. For example, the data came to you into the raw data, and then furthermore, the way the data could be presented to the application, especially at the presentation layer, the data is coded and decoded. Like the presentation layer works to transform data into form that the application layer accepts. For example, you send all the data encrypted. Yeah. So until the application layer decrypts it, yeah, it would be the responsibility of, until the application layer could understand it. Yeah. The application layer needs a clear, password. For example, any data which should not be decoded, it needs a pure text, but before the text is being received at the presentation layer, it is the responsibility of the presentation layer to either check if it was coded or encoded, then they need to decode it and then present to the presentation layer. Make sense?
Yes.
Because until the transport layer is would be the middle line. Yeah. And the data would have been received from the network layer and the data link layer and the physical layer. So possibly no one knows until it reaches to the presentation layer that what is the meaning of the data. Yeah.
Okay.
The meaning of the data could be encrypted, could be decrypted, it could be a plain text, it could have some algorithms applied so that no one could be able to understand it. Then at the presentation layer, it has to kind of a serving of the dish. Yeah.
Yeah.
So the whoever wants to serve would know that what to serve, where to serve, and how much needs to serve. Yeah.
Yeah. Correct.
Then furthermore, the application layer, this is basically the application and the end user process or communication. Yeah. So the communication partners are identified, quality of service is identified, user authentication, privacy are considered, and any constraints on the data syntax are identified. So pure data is given to the application. Obviously, for example, if we say the join me has a the application interface, yeah, but join me is showing you the contents of the screen to you, isn't it?
Yes.
Yeah. So it is the responsibility of the application layer to show the user, yeah, anything via authentication and actual, the data. Yeah.
Yeah.
So the furthermore, this layer supports the application, and we should discuss this. And everything at this layer is application specific. Yeah. These at the 7 layer, it is the pure form. For example, if it is the email, then you don't need anything else for the further processing. You would get the data into the email form. You would get the data into the any particular application form, isn't it?
Yes.
Yeah. Now, if you want to remember this, the layers of the OSI model, then you can always remember this phrase, please do not throw a sausage pizza away. Yeah. So removing this, you can say the P, physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Like when you learn the typing, you must have used a quick brown fox jumps over the lazy dog, isn't it? Did you
Yeah.
ever use this?
Yeah.
Yeah. So this is a kind of trigger, a mnemonic, which you can use. Now, furthermore, if we could have a look on the, uh, OSI model and see where these, uh, layers exist and what kind of, the uh, protocols and applications and everything is being used into, okay, let us leave this picture, a bigger one, and then I would resize into the,
Okay.
yeah. So at application layer, the emails, the news groups, web application, file transfer, host, sessions, directory services, network management, file services used. At the presentation layer, POP, or SMTP protocol Usenet, HTTP, FTP, Telnet, DNS, these protocols are used. Yeah. So because HTTP would be dealing with a response of the request, for example. The
Yes.
sessions are being maintained if it is a connection oriented or the connectionless, then POP 53280, these, RCP protocols are used. Transport layer, the TCP protocol is used, or UDP, user datagram protocol. That's a kind of, they would be deciding, yeah, that from where the computer and the network, they distribute, as well as they would be deciding that the type of the protocol. The TCP is basically the connectionless protocol. Yeah. And if you want the connection oriented protocol, then you would be using, the UDP. Yeah. And there are lots of protocols that would help you to decide in between the type of the communication. Yeah. Then the network layer would be using the internet protocol, for example, the internet protocol 6, or the 4, where the IP addresses would be dealt. Yeah. Then the data link layer, when the bytes are converted into the bits, or bits are converted into the byte, are being done with the SLIP, PPP, these 802.2 standards, Ethernet one. Yeah. And the physical one, exactly RX, the category 1, ISDM, ATM, FGDI, the topology, and further, the way the data should have been, logically transmitted. Yeah.
Yes.
So that's basically the OSI model reference and corresponding, the applications and the protocols. Yeah.
Yeah.
Now, TCPI model. TCPI model is basically the transmission control protocol. It's a network model used in the internet as an architecture. These protocols are set of rules which govern every possible communication over a network. These protocols describe the movement of data between the source and the destination. So, for the internet, this is a kind of concrete protocol, a practical standard. Yeah. And however, the OSI model is a kind of the an abstraction. The devices which are being made, yeah, they are not part of the internet, for example, but they are supposed to follow those the standards. However, for the internet, these layers must have been the used. Yeah. With if you want the communication over the internet and the internet uses the TCP, then they must have to follow these layers. Make sense?
Yes.
Okay. Furthermore, the TCP has got the layers at the physical and data link layer, which is called the network layer. Upon it, setnet, packet ratio, and LAN work over there. Then in the IP at the network layer, the IP protocol is used. In the transport layer, the TCP/IP and the UDP protocols are used. And at the application layer, yeah, you use telnet, FTP, SMTP, and DNS. Yeah. In the OSI model, the application was a kind of the user application, isn't it? But
Yeah.
the TCP understands the DNS, SMTP, FTP, telnet. They are as an application, and it has the transport protocols, TCP, IP, and UDP, and the network IP, and the physical data link layer is which is called the network access layer, would be using these protocols. Yeah.
Okay.
Now, how they have divided? They have basically divided, or further, classified that the data link layer and the physical layer is converted into the network access layer. Yeah. If you remember that we were talking about the network layer should have been the last layer before the physical layer and the data link layer, isn't it?
Yeah.
Yeah. So they have put the network layer, yeah, which includes the data link layer and the physical layer over here. Yeah. And they have put like an internet layer as a network layer. Yeah. And the transport layer is at the same level. However, the session layer, the presentation layer, and the application layer have been converted into the one application layer. Yeah.
Okay.
Make sense?
Yes.
Yeah. Then furthermore, the comparison between the OSI and the TCP/IP is given here. OSI is a generic protocol, yeah, while the TCP/IP is a model based on the standards. OSI model, the transport layer guarantees the delivery of the packets. However, in the TCP/IP, it doesn't. Follows vertical approach, follows the horizontal approach. The OSI model has a separate presentation. The transport layer is a connection oriented, yeah, and in the OSI and in the TCP/IP does not have a it's not connection oriented. I mean, it's a connection oriented as well as connectionless, because if you are referring the OSI, then it must be the connection oriented, for example. But when it comes to the TCP/IP, you can have a both. And the examples
Okay.
are, for example, if you want to browse the web page, then it is a connectionless. But using the same TCP/IP, if we are doing the voice chat, then it is a connection oriented, isn't it?
Okay. Yeah.
Yeah. And then in the OSI, the network layer is both connection oriented and the connectionless again. Yeah. and in the TCPI, it's a connectionless.
Okay.
Yeah. So furthermore, some of the more differences are discussed here. Yeah. And then there is a is it okay if I should skip, these theoretical differences?
Yes, it's fine.
Yeah. Then there is a network tomography. Yeah. The network tomography is the study of network's internal characteristics using information derived from the endpoint data. So basically, that's kind of the monitoring of the network. Yeah.
Mm-hmm.
Yeah. And furthermore, all the characteristics. And then there is a term root cause analysis. Yeah. So the root cause analysis is a topic. Yeah. Is a systematic process for finding and identifying the root cause of a problem or event based on the basic idea that have a truly effective system means more than just putting out the fires all day. The RC aims not to only figure out where the issue is, but find out that how to prevent it. So behind this idea of the root cause analysis, certain softwares are basically designed. Yeah. And the root cause analysis should need to work according to the principles that focus on corrective measures. Yeah. Perform most effectively when accomplished through a systematic process. So when you try to try to focus on corrective measures, you need to have a systematic process. Yeah. And there could be more than one root causes. Yeah. So you need to know the principles of the root cause analysis, because we are trying to monitor in the problems into the network. Yeah. Problem is not a problem when, let's say, if we are communicating and if the connection is totally lost, we cannot communicate. No, the problem could be the slow. The problem could be the bandwidth. The problem could be the quality, isn't it?
Yes.
Yeah. So network tomography, you look at into the detail and find the root cause, because these are the topics of the cause analysis. And the root cause analysis is basically the identifying the causes as well as trying to know the reasons behind. Yeah. And how you can do the root causes, you can know the root causes using the principles. Yeah. And what steps you need to know in order to know the root cause. So probably you define the problem, gather all information, identify any issues, determine the root causes, identify the recommendations that how to they reoccur, and implement the necessary solution. Make sense?
Yes.
Yeah. So how you can use the tools like a SolarWinds and Netmon, Liber, NMS. These are the softwares, and I have given the links to those websites which are producing, which they have created these softwares for analysis and monitoring of the networks. Yeah.
Okay.
Right. So overall, we try to cover as much as possible, and the major things were the OSI, which was developed by the ISO, and we discussed the 7 layers, and the 7 layers has a kind of middle layer, which is basically the transport layer. And then the TCPI model is the a kind of practical layer, model. Yeah. And it has been derived from the with comparison of the OSI model. Yeah. And there is a certain comparison in between. Then the network tomography is the study of investigating the problems of the network into the depth, and you can use the idea of the root cause analysis, which has some principles, and using these softwares. Yeah.
Okay.
So I think it should be fine. And if you have any questions, then you after further study we can discuss into the next session or via email. So hopefully after the last session, your course would have been completed fully. Yeah.
Yeah.
And I
The
will.
next session, I guess, is on next to next week.
Sorry.
The next session is like somewhere on 9th.
Yeah, hopefully on the Monday, and the 3 p.m. Is it okay?
Yeah.
Okay, that's fine. In case if I we wanted to change the schedule, then I would let you know. But let us get
No
it done,
problem.
as soon as possible. Yeah.
Yeah. Okay.
Right. And we discussed about it, and I have sent you the email, and I would be referring to the email so that I could respond to you accordingly. Yeah.
Okay.
All right. That's fine. Thank you very much, and bye.
Thank you so much.